Hello everyone, and welcome back to another video from Maths Problem Solving. Today we're going to be looking at a geometry question from an SMC. So here's just the flowchart which briefly maps out what we're going to be doing. We're asked to find out the area of the shaded region. So we basically need to split this into two logical plots and work out the area of them individually and use a bit of the information which the question gave. And yeah, a bit of trigonometry as well. We'll touch on this in more depth towards the end. Let's get into the question. So this basically shows a rectangle with length 6 and 12 as the two as the two side lengths to this rectangle, and this is a tangent to this circle. So let's just label the center over here. What the question is asking us for is this shaded area. So basically this shaded area, we can map this out into 4 sections. 2 of these are sectors, which we can work out using the sector and area formula, and the other 2 are triangles, which we'll have to use like area sine rule probably to work them out. So yeah, let's just get into it. So if we label this angle as theta, we can label this angle as 180 degrees minus theta, since they're both on a straight line. We can also label this angle as theta, and this angle is 180 degrees minus theta. These 2 opposite triangles and 2 opposite sectors are congruent. Like just visually as well, it looks like it, but I can prove it. I won't now. Let's just get on with the actual question. So we need to basically work out what theta is. That will help us significantly. So we know that this particular side length is 6, and we know that this is 12 over here. These 2 are both tangents, therefore this line which I just drew over here, that must be the diameter. The length of the rectangle is 12, therefore the diameter must be 12 as well. Therefore, the radius is 6. If the diameter is 12, the radius has to be 6. Let me just rub out a lot of this stuff because our diagram will start to get very congested. But now we know that the radius is 6, we can use this information to work out a few other things. I'm just going to relabel theta on here. That's important for now. This is 6, this is 6. Therefore, the area of this triangle would just be 6 times sine theta times 6 times a half. That's the area of a triangle. And the area of the sector would be 6 times 180 minus theta times 6 as well, divided by 360 degrees. Okay, now let's just work out what theta is in this question. Now, the way which we'll need to do this is actually consider this triangle over here. Now, this length over here is 6, and so are these 2. So now we know that this has to be an equilateral triangle, right? Therefore, this angle over here, we know that that's 180 degrees minus theta. Since it's an equilateral triangle, that basically equals 60. Therefore, theta equals 120. That is the main portion of this question. If we work out that angle, we can do wonderful things. So let's work out the area of this triangle now. I'm just going to rub out this radius equals 6. So we know that theta is 120. This is 6, this is 6. Therefore, the area of this triangle would equal 6 times 6 times sine of 120 times a half. Now, sine of 120 is the same as sine 60. If we just look at like sine's curve just quickly, we know that it has symmetry every 90 degrees. Therefore, anything which is here is going to be the same as its respective value over here. Therefore, sine 120 is sine 60. So 36 times a half times sine 60. Sine 60 is root 3 by 2. Therefore, this just equals 18 times root 3 by 2, which equals 9 root 3, as the area of this triangle. Now, the area of the opposite triangle would just be the same. So therefore, the area of both triangles, if we just, area of both triangles equals 9 root 3 times 2, which is 18 root 3 centimeters. We'll come back to this a bit later in the question. Now let's work out the area of the sector, okay? So the area of the sector is just this angle over here times the radius, times the radius, times pi r squared, and this angle divided by 360, okay? So therefore area equals 180 degrees minus theta, which is that angle, divided by 360 times pi r squared. Okay, 180 degrees minus theta, that's 120. So this just equals 120 divided by 360 times 36 pi. Because r is 36 and 36 pi is our area. So that just equals 36 pi divided by 3, which equals 12 pi, as the area of one of these sectors. Now, since both sectors are congruent, we can just multiply this by 2. So area of two sectors equals 24 pi. Therefore, the total shaded area would equal 18 root 3 plus 24 pi. 18 root 3 plus 24 pi. And that is our final answer. Let's just see which one it reconciles with. 18 root 3 plus 24 pi, which is basically answer E, which is our answer. Let's just go back to the flowchart and see the steps which we did to work this out. So we basically split this up into two logical parts, and we had to work out the area of both of them. One of them was a sector, one of them was a triangle. Let's just go through how we did the triangle. So we know that the triangle, the angle between the two radii was 120. We recall that 120 equals sine 60, which equals root 3 by 2. Used area sine rule to work out the area of that triangle. Now, we knew that the area, the angle of the sector was 180 degrees minus theta, which is 60 degrees. Therefore, 60 degrees, we just used 60 degrees times pi r squared divided by 360 degrees to work out the area of one of the sectors. Multiply both of them by 2, and we got our final answer. So yeah, I hope you enjoyed that video. Hopefully you learned something new. And yeah, if you did, please be sure to leave a like and subscribe. That would be very much appreciated. And I hope to catch you next time. Bye.